So hey everyone, in this video we are going to discuss about an expression of electric field due to the electric dipole on its axial line, and also we will find out the electric field on the equatorial point due to the dipole. So let's get started. First of all, we will find out the electric field due to the dipole on axial line. So first of all, I'm assuming that everyone know the electric dipole, but still I will tell you what exactly is electric dipole. Let's suppose these are the two charges, and everyone know what exactly is electric dipole. Electric dipole is basically a system. There will be the two charges having same magnitude, but their sign will be the different. One charge will be the positive and one will be the negative charge. Okay, but the strength of this charge, the magnitude of these both charge will be the same. Okay, what we have to do is in this expression we have to find out the electric field due to this dipole on its axis. And if we stretch this line, if we stretch this line like this, so this is what? This is an axis of this dipole. Okay, and this line also known as the axial line. Okay, let's suppose this is the point P, and we have to find out the electric field on its axial line at point P. And every time we assume there will be a charge, there will be a test charge, and that test charge will be the positive. Okay, hope this is clear. Let's suppose this is the midpoint of this dipole, and let's suppose this distance is a, and this distance is also a. Okay, and from the midpoint of this dipole to the this point to the this point, the distance is r. We are assuming from the midpoint of this dipole to the point, the distance is r. Okay, we have to find out the electric field at this point. Okay, so this is what positive test charge, and here is what positive charge. So the positive will repel, and the electric field will be in this direction due to the positive charge. Okay, fine. And there is a charge q minus, and here is what? Charge plus. So due to the opposite nature, the electric field will be in this direction because they will attract. Okay, so the electric field will be the minus in this direction. Okay, fine. So the from this positive charge to this point P, how much will be the distance? From the midpoint to the this point, the distance is r, but from this point, from this positive Q to P, the distance will be r minus a. R minus a. Why r minus a? Because of the whole distance is r from the midpoint, and this much distance is a. So if we subtract this much distance from this, so we will get this distance from positive Q to P. Hope this is clear. From this negative point to the this point P, this distance will be r plus a. Okay, as you can see, this much distance is a, and from midpoint to the this positive point, positive test charge point, this distance is r. So the total distance will be r plus a. Hope this is clear. Now what we will do, we have to find out the electric field, but here are two electric fields, but there will be the only one electric field, that will be the net electric field, and net electric field will be the electric field due to this positive charge minus, and this electric field due to the negative charge, because as you can see here guys, this positive charge and this positive charge are closer, so the strength of this electric field will be higher than the strength of this electric field due to this minus charge, because the minus charge is too much away from this positive test charge. I hope this is getting. We all of know that whenever we have to find out the electric field due to charge at a distance r, let's suppose this is the charge and here is point P, and we have to find out the electric field at this point P. So the what is the formula to find out the electric field? So the formula is 1 upon 4 pi epsilon naught q upon r square. Okay, so everyone knows this. So what I'm going to do is, let's suppose this is equation number 1. Now what we will do is, first of all, we will find out the electric field due to this positive charge. So the electric field due to this positive charge will be how much? The distance is r minus a. So the 1 upon 4 pi epsilon naught. So the charge is q upon r square. But instead of r square, what we are going to do is, the distance is r minus a. So, so this is the electric field due to this positive charge. And similarly, due to the negative charge, the electric field will be 1 upon 4 pi epsilon naught q upon r plus a ka whole square. Now simply we are going to put all these values in this equation. So what we are doing, just we are putting these values inside this equation number 1. So 1 upon 4 pi epsilon naught, this is q r plus a ka whole square. So what I can do is, I can find out 4 pi epsilon naught, and also I can take q also common from these two, and inside it will left with r minus a ka whole square minus 1 upon r plus a ka whole square. Okay, now it is just a simple calculation is there, and we will do it. So this whole term will come here, r plus a ka whole square, and this whole term will come here, r minus a ka whole square, and the multiplication of these two terms will take place. Okay, I'm assuming that you guys know this formula. A plus b ka square is what? A square plus b square plus 2ab. A minus b ka whole square will be a square plus b square minus 2ab. And there is one more formula, a plus b into a minus b will be equal to the a square minus b square. I'm assuming that you guys know all these formulas. So now the simplification is there, simple calculation is there. So q minus 4 pi epsilon will be as it is. Now what we are going to do is, we will simplify this, a square plus b square plus 2ar minus r square plus a square minus 2ar, and this will become this. So okay, first of all I will write like this. I can write like this. So again, 1 upon 4 pi epsilon naught. So the r square plus a square plus 2ar minus r square minus a square. This minus minus will become plus, so 2ar. And what I can write for this, a square minus b square. Okay, so r square minus a square the whole square. Okay, now q upon 4 pi epsilon naught is there. Simply this will get cancelled out, this will get cancelled out, and 2 times 2ar divided by r square minus a ka whole square, and this bracket ka b whole square. Okay, fine. So there is one concept that we have learned, which is dipole moment, electric dipole moment. and electric dipole moment is P, and the formula of this P will be Q into 2A. Okay, we discussed already in the previous lectures. So what I can do, 2R, just wait a minute. I can write this as 2R into 2A into Q upon 4 pi epsilon naught, and here will be the 2 square, sorry, R square minus A square ka whole square. This 2R will be as it is, and for this I can write P, and P is nothing but P is dipole moment, electric dipole moment. This will be 4 pi epsilon naught, and this is R square minus A square the whole square. Okay, so this is the expression we got, 2rp upon 4 pi epsilon naught R square minus A square the whole square. And this is the equation or the formula for the electric field on axial point due to this electric dipole. Hope this is clear. Now we will take some cases on this formula. Case 1. Let's suppose our this distance. Okay. Let's suppose this R is too much compared to this A. Okay. Let's suppose R is far away from this A, and compared to this R, A is very small, and we will neglect this A. So A will be negligible. Negligible. Maybe the spelling will be wrong, but it's okay. So the formula is we have, so 2rp divided by 4 pi epsilon naught. So we will neglect this whole term. So the R square ka whole square. So 2rp upon 4 pi epsilon naught, and this will be the R to the power 4. So this R and one R will get cancelled out from here. So the power 3 will remain. So the 2p upon 4 pi epsilon naught R to the power 3. If we consider this case. Okay, hope this is clear. Now we will derive an expression for the electric field due to the electric dipole on the equatorial point. So here is again we are going to draw an electric dipole, and as I told you already, electric dipole is a system where there will be the two charges having same magnitude, but one charge will be negative and one will be the positive charge. And what exactly is the equatorial point? Equatorial point is basically a perpendicular bisector of this electric dipole. So let's suppose this is point, and at this point we have to find out the electric field on equatorial point. Equatorial point, as I told you already, equatorial point is a point or a line which is dividing this electric dipole equally. So the this portion and this portion will be the same. Let's suppose from the midpoint of this electric dipole, this distance is A, and this distance is also A. Okay, fine. And here is our point P, and let's suppose there we have kept a positive test charge. Okay, and let's suppose from this midpoint to the point P, the distance is R. If you see this figure carefully, you can see this is making a right angle over here, and here is also it is making 90-degree angle. So if I draw this line, so this will look like this, and here I will draw again this line. So we know the Pythagoras theorem, PGT. According to Pythagoras theorem, hypo ka whole square will equal to the this base ka square plus height ka square. height का square, isn't it? And let's suppose we have to find out this distance. Why we are finding this distance? Because we have to find out the electric field. Okay, I will tell you why we are finding this distance. Okay, so the first thing we have to find out the hypo. Okay, base is we have a, इसका square बन गया, and height is we have r. So the r square will be here. I have to find out this hypo. So what I need to do is I will take the square root of this. So the hypo will a square plus r square. Okay, so this distance will be a square plus r square. Okay, and similarly this distance will be the same because all these parameters are the same. So the a square plus r square under root main. Okay, fine. We already discussed key. Let's suppose we have a charge q, and let's suppose we have a point p at a distance r, and whenever we have to find out the electric field at this point p, so the electric field will be 1 upon 4 pi epsilon naught q upon r square. Okay, isn't it? So at this point we have to find out the electric field, and for that we have calculated this hypo, this distance. Okay, hope this is clear. And I'm going to erase all these things because this was very basic. Now what we will do here is what negative q charge, and here is what positive q charge. So there is a positive charge and negative charge. So there will be the force of attraction will be here. Okay, and force of attraction will be in this direction. Okay, and electric field due to this negative charge is this. Okay, fine. And here is what we have positive q charge, and here is also positive charge. So the electric field, first of all, there is what force of repulsion will be there because the sign of these both charges is same. So the electric field will be in this direction. Electric field due to this positive charge will be in this direction. Okay. Now, first of all, I will find out the electric field due to this negative charge, and that will be equal to the 1 upon 4 pi epsilon naught upon the distance is what root a square plus r square whole square. Same for the positive charge. The electric field will be 1 upon 4 pi epsilon naught q upon r square. At the place of r square, we are going to put this value plus r square. So in this figure, this side is equal to this side. So this is what this figure is making isosceles triangle. Okay, so this will be the same angle as this angle. Okay, both angles will be the same. If you clearly see this figure, I can draw a parallel line with this line. So our parallel line will look like this. So this angle is what theta, and this is what parallel line. So according to the property of parallel line, so this angle also can be theta, isn't it? Okay, and if we consider this angle, this, okay, this angle will be equal to this angle due to the interior angles. There is a property of interior angle. Interior angle becomes equal just because of these parallel lines. Okay, fine. Uh, this figure is looking very messy, so I will draw here so you can see clearly. So this is what electric field due to the positive charge, and this is electric field due to the negative charge. Okay, fine. And this was our parallel line. Okay, this is making angle theta. This is also making angle theta. Okay, fine. In previous standard, we have learned how we can resolve the vectors. Whenever we will have an vector, we have learned resolution of that vector. Why we need to resolve the vector? Because we have to find out the net electric field. Okay, so that's why we are going to resolve these two vectors. First is there is e plus, and there is e minus. So for the two times we need to resolve this vector. So this is for the first, we are taking this as e plus, okay, and this is angle theta. So this component will become e plus cos theta, and this component, okay, I will draw it again, and this component will become e plus sin theta. Okay, this is for the plus charge, this electric field due to the positive charge. Now we will resolve this line, this vector. This is making angle theta. This is what e minus is we have. So this will become e minus cos theta, and this component will become e minus sin theta. Okay, as you can see in this figure, this e plus sin theta and this e minus sin theta both are in opposite direction. So they are same in magnitude, but their direction is different. So they will cancel out each other. So this component will get cancelled out, and this also will get cancelled out. But as you can see in this figure, this e plus sin theta and e minus sin theta both are in the same direction, and the direction is this. So the e minus sin theta, sorry, yes, sorry, this is cos theta component, not sin theta. E minus cos theta and e plus cos theta both are in the same direction. Now their magnitude is also same. Okay, now I will just clear this. From this figure we can say that the net electric field will be in this direction, and the net electric field will be the electric field due to this component plus electric field due to this component. If we add these two components, so this will look like this. So this is what r square, and here will be the cos theta component. And for the cos theta, what we can write here, you can see cos theta is what, adjacent side upon hypotenuse. What is the adjacent side? Adjacent side is a upon hypotenuse is a square plus r square. So instead of this cos theta, what I can write? So first of all, I will take q upon 4 pi epsilon naught a square plus r square ka whole square as common, and here will be the 2 cos theta. Q upon 4 pi epsilon naught root a square plus r square is ka whole square. We have taken common from these two. Now simply at the place of this cos theta, what we are going to do, we will put this value a upon root a square plus r square. So q upon 4 pi epsilon naught root a square plus r square ka whole square 2 into at the place of cos theta. So just wait a minute. So 2 at the place of cos theta a upon this is we have q and this is a square plus r square. So this will become 2q, this is a 4 pi epsilon naught. So here is power a square plus r square. It will become after squaring this. So the under root will get removed into here is a square plus r square to the power half. So the 1 plus 1 by 2 it will become, I'm adding these powers, so it will become 3 by 2. So overall power of this whole term will be 3 by 2. Okay, 4 pi epsilon naught. Here will be the a square plus r square to the power 3 by 2. 4 pi epsilon naught a square plus r square to the power 3 by 2. So as of now, we already discussed this whole term will become electric dipole moment. An electric dipole moment we will represent by P. So the 4 pi epsilon naught a square plus r square 3 to the power. So at the end, this will become P upon 4 pi epsilon naught a square plus r square to the power 3 by 2. So this is what? This is the electric field at equatorial point P. This was the equatorial point P due to this electric dipole at distance r. Okay, so electric field was this much as we have calculated. Fine. If we take one more case, let's suppose we take case if we consider the distance r square is far greater than a, so we can neglect this a. Okay, and electric field will become p upon 4 pi epsilon naught. We can neglect this a, so r square 3 by 2. So at the end, this will become 4 pi epsilon naught. So this will become r to the power 3. Hope this is clear. And you can take the screenshot of this derivation. I would suggest you to take this screenshot in two parts. So take the first part from here. Okay, fine. Now take this much part. Okay, fine. I hope this is clear to you guys. एंड चलो मिलते हैं अगली किसी वीडियो में, तब तक के लिए पढ़ाई करते रहो. ऑल द बेस्ट.